I'm Jennifer Nix. I'm with the Federal Highway Administration. I've been there just over 9 years now, and I find it very rewarding. One of the first trainings that I ever took when I got there was this class called Leap, Not Creep. See, FHWA was embarking on a new initiative, the Everyday Counts initiative, which was about accelerating market readiness for proven innovative technologies. Now, one of those technologies that I was lucky enough to work on with my coworker was geosynthetic reinforced soil. Now, geosynthetic reinforced soil is not new. It's been around since the 1970s, so we're talking about 50 years now of this innovation. And basically, it's just very simple: stack and compact. Layers of compacted aggregate, reinforcement, and continue. Now, this technology has been used for retaining walls primarily in the past. It's also been used for rockfall barriers, blast protection. It's a very robust type of system. Now, the thing that FHWA was working on was, how do you do this and support load-bearing structures? We've done a number of load tests that show it can withstand great loads, well beyond what you would have for bridges. And you can see from the picture in the middle, even when it fails, we're not talking catastrophic failure. So this is an amazing technology, something that should be delivered. And from that, now we have over 300 bridges that have been delivered into the United States and abroad. So what's the problem here? Why is this technology gone rogue? Now, what do I even mean by going rogue? Well, the term actually started out with elephants. It was that erratic behavior, a wild, vicious elephant that was, away from the herd. Now, I don't consider myself wild and vicious, maybe at 2 a.m., you never know. But so from that, the actual definition of gone rogue from the dictionary: exhibiting maverick-like behavior or bucking the status quo. Well, you saw from the technology, how does that buck the status quo? It's doing what it should be doing. It's designed as it should be designed, or is it? Now, the issue is, it's not the technology and bringing it into load-bearing applications for bridge support. Now, one, that's also different because this is a shallow foundation type of technology. And most bridge engineers want to found their bridges on deep foundations. So that was one way you're bucking the status quo. You're putting a bridge on a shallow foundation. The other challenge was that we had to create a new design for this system. Now there is, you have the typical ingredients of backfill, geosynthetic reinforcement, a facing element. All of that leads itself to, okay, it's a typical MSC technology. Well, not really. If you design this system with current practice, with the ASCE FHWA standards for MSC technology, you get something very different. It would actually say that what we're building now with the GRS integrated bridge system would have a factor of safety of 0.05. It would fail. How is this possible when we know empirically that this system supports all these loads and performs excellently well? I have two pictures here. On the right side is what you would get if you designed it according to current practice. Now, theoretically, it can be done, but is it efficient? Is it optimizing the technology? On the left, we have what our new design philosophy created. And this is something that was developed with a lot of research. We didn't just go into this system bucking the status quo just for the sake of it. We had a purpose, and that was really to go and eliminate what do we not need, what can we do to be cost effective with these bridge designs. So you can see from the right, you have a longer bridge span. Now that increases your cost. You have to have longer reinforcement lengths. That increases your excavation. You have an approach slab, sleeper slab. So let's eliminate all those materials that are unessential for this technology. You can really optimize and put the bridge directly on that foundation, eliminate the need for an approach slab. You have now an integrated approach created with geosynthetic reinforced soil, which has actually been shown to eliminate that or alleviate that bump at the end of the bridge, which I think we all want to deal with less of that. And you can reduce the excavation limits. So by bucking the status quo, it wasn't just going from deep foundations to shallow foundations. It was really going from a new design, from typical MSC technology to this new geosynthetic reinforced soil integrated bridge system. So what's the problem? Well, there's a lot of resistance out there, not just from bridge engineers who are typically conservative and want to make sure that the bridge stands, which this does, but there's also this ingrained root of people who have been working for those last 50 years on geosynthetic reinforced soil. They already have created a design. What's wrong with that? So that was a big hurdle, and like I mentioned, there's a lot of controversy that surrounded that. A lot of that resistance that we found, and I was clearly not knowing what was going on that. And again, these are your bread and butter bridges that we're talking about. Between 70–80% of our 600,000 plus bridges in our inventory are these single span bridges. And really, if you think about it, nowadays, a bridge goes out. Do they have money? Does the county, does the agency have money to replace it? Oftentimes not. So then what, do we just close the bridge? No, I mean, with this new GRS IBS, it saves almost up to 60% in cost. You can build it in a few months. So it really is a good solution to replacing these bread and butter bridges. Now, so where are we at? Why was there this gap within what was current practice, the GRS, MSC type walls, and the integrated bridge system? And I go to this technology gap. And this is beyond just GRS. This goes for any innovation that you might see. We have best practice and state of the practice. This is what typically practitioners go to. There's standards, there's codes, there's design methodologies that people can follow. It's safe. Now, you also have the subject matter experts, let's say more on the academic side, those that focus particularly on a specific topic. And that's a big leap forward nowadays. It's going at a faster pace, a faster rate than one might be able to catch up with. And not to say that practitioners can't be subject matter experts, obviously, but they often more tend to rely on the code and what's there. Now, why? I mean, could it be liability issues? Could it be, it's just, we know it works. Let's go with what we know. Why should I take that leap forward? It's conservative. What's wrong with that? We know it's safe. Am I going to put my life on the line for this when I have to just, stamp design plans? So really, I mean, we have these codes and standards and specifications out there, which aren't necessarily a bad thing. We need that minimum standard of care. But how then can we leap forward and innovate and get new practice into the system? I mean, with the GRS IBS, even from the Federal Highway Administration, we created design and construction guidelines. That's not even because it wasn't in the ASCE specifications, a lot of states were resistant to even take that forward. Again, and we're Federal Highway, we're saying this is a good system, this is how you should design and construct, but there was that resistance because it wasn't a specification. So then what do we do? Well, again, like I mentioned, this is beyond just the GRS IBS. It's really with all technologies. And there's really an invention cycle that goes around. It starts with imagination, you go then to creativity, innovation, and then entrepreneurship, which is the actual application. Now, when I came in, this system had already been developed by my coworker, Mike Adams. I was lucky enough to be able to get in there, and he knew empirically that this system worked. It was now time to put pen to paper and actually develop these design and construction guidelines. So you keep going on this invention cycle, and it keeps going. You don't want to stop. Just because we now have these design and construction guidelines, things can always be advanced, be improved. Because ultimately, as civil engineers, we want to optimize our designs in a safe and reasonable manner. So with that, I want to encourage you to look at Peter's laws. I don't know if anybody's been aware of this. It's Peter's laws, the persistent and passionate mind. They actually changed that. It was actually the sociopathic, obsessive compulsive person. I didn't want to call myself that personally, so I'll just call it persistent and passionate. And he has 28 laws. I won't go through all of them. I just, again, encourage you to look into it. And really, I put in some of the ones I thought were some of my favorite. Do it by the book, but be the author. Check, I got my design and construction guidelines. If you can't win, change the rules. Just because something's out there in codes and specifications doesn't mean you can't take that leap forward, as long as you know it's safe and it's going to work. Don't walk when you can run. And especially being a government worker, I can honestly understand and relate to the last one. Bureaucracy is an obstacle to be conquered with persistence, confidence, and a bulldozer when necessary. So with that, keep going rogue, cross that bridge as it comes, and I thank you for your attention.